All right, so what I'm going to talk about today is I'm going to explain all topics we have learned today and what kind of connection is available between these topics. Or in general, I'm going to talk about the big picture of data analysis topics we have learned up to this point. Okay, so let's go back and see what topics you have learned. You have learned associations, right, or relations, and you have learned differences or groups. So associations, it could be between two continuous variable or two categorical variables. So the first one, if it's between two continuous variables, we used a different method, right? What did we use? We used scatter. So look, when I say big picture, I want you to see all of these topics at the same time, and you can analyze any data set you receive. I want you to be able to analyze these all at the same time, not separately. So you have to connect these in your mind, okay? So scatter plot, so I won't write the word plot, but scatter, and then you need correlation. What else do you need? You need R square, and you also need R square, you need regression, simple regression model, SRM, simple regression model. Then you need to check the assumptions or conditions, right? SRM conditions, SRM conditions. So you need to check those, which includes residuals to be normal, residuals to be independent, residuals to have equal variances or homoscedastic, right? So if you had two categorical to categorical variable, what did we have? Mosaic plot. That's something similar to scatter plot for us. Then we have chi-square value. What do we look at here? P-value to be, P-value is important here. And then we also look at Cramer's V values, right? What else do we have? I've missed something here. Can anyone help me to add one more thing here? Start with the C. Do you remember what I'm missing? I help you another thing, CO. Cool, that's for regression, no. Yeah, it's a table, so I add a table. One of this you can set table. That's Jasmine, that's correct, table. What, yes, Cambry, perfect. Contingency table. So we need a contingency table, and from there we need a Mosaic plot, and then chi-square value, and Cramer's V. Perfect, so you're all good. Cramer's V. Attach this. Okay, so that was for relations. Do we have anything else for relation? Did you learn anything else related to relations, association? There's one more thing, multiple, continuous, right? IVs, and A, continuous, DV, or response, right? If you have that, again, we use scatter. This time is not scatter plot, scatter matrix, scatter plot matrix. Let's do it. Correlation, Pearson correlation matrix. What else do we need? Of course, we need R square again. What else do we need? Multiple regression model. Multiple regression model. What else do we have to check? Anyone? What's the last part? When you have the model, when you have the regression equation, what do we do? Check. ANOVA is one of them, yes. If that's what you mean, that I mean, then yes. But ANOVA, you can call it ANOVA. It's already written in this page, so you can find it somewhere here. Can you find it? Check. Multiple. Yes, the three tests are one part of it. Check multiple regression conditions. So same as SRM. SRM conditions is for simple regression model. It's only the p-values to be below 0.05 of the regression, and residuals to be normal, residuals to be independent, residuals to have equal variances or homoscedasticity. But here, for multiple regression, there are more. So that's why I separately write multiple regression conditions, SRM conditions. There are similarities between these, especially for residuals, they're pretty much similar, but we have other things added for multiple regression conditions. Okay. All right, so we have associations. So let me make this like red. And this also red. So that we can have a better understanding. Okay, how about for differences? So differences is between categorical or groups or grouped, right? Grouped IV to, so we're actually trying to see if there is effect from a categorical IV to a continuous DV. All right. So, and then I add here depend on number of groups, depend on number of groups, you run a different analysis, run different analysis, right? So that's one thing. But what kind of analysis did you learn here? There were analysis you have learned in Stat 1 or in basic statistics in the past. So I don't want to repeat those because those are for lower level of statistics. For data analysis, we use normally for most problem solvings, we use certain analysis, and I'm going to write those. So if you have, if the cat variable, which is categorical variable, has two groups, then and these groups are independent, two independent groups, right? What do? We use independent t-stat test. Independent t-stat test. Okay. Why do we say independent test? Because these groups are independent, they don't influence each other. Do we have the opposite? Yes, there are groups that are associated. They are grouped, but these groups are associated. Imagine we want to see if there is a significant difference between average grade of male and female students in our class, right? Students in a class, male and female students in a class, they are not associated. Why they are not associated? Because they don't help each other. I mean, each male and female student don't help each other. Sometimes maybe a male student help another student. Sometimes there's no help. Sometimes a female helps another female student, or female student help male student. There is no certain way we can say they're related, they're associated in grades, right? But imagine you have an example where you go to families and ask these families that they have, for example, low salary amount. So we are selecting samples to understand what happens to low salary families, right? So we go to homes of these families, or we interview them and ask them questions, and the man and the woman in that house, they give responses. These responses are associated. Why? Because these two people are living in the same house. They have almost the same opinion. They have, or even if it's not the same opinion, their opinion is influenced by similar factors. So they are associated. So for those cases, we do not use independent t-test, because independent t-test is assuming that we have independent cases. The cases, the groups, they don't influence the other. Male groups don't influence female groups. But there are groups that they are associated. For them, we use a different test. That test is not covered on your exams, okay? I'm going to explain it right now, but it's not covered. I will never ask. I just want you to have that big picture. So if the groups are independent, we use the t-test, look at the p-value below 0.5, that means there is a significant difference. So let me add up here for all of these analysis, we reject HO if p-value is below, p-value is below 0.05, okay, for all of them. And for all of them, if it's a relation, what's the hypothesis? HO, there is no significant relation between IV and dv, and remember you will say the name of the IV and dv. For HA will be the same but in a positive form, right? Let's copy this and paste it here. Okay, that's for relation. For differences, for difference or for groups, look, I can also copy for, even for differences, I can copy this, just change it a little, and that would satisfy what I want to do. There's no HO is, there's no significant difference. But here's the thing that many students make mistake or get confused. What's the difference about? Is the difference between IV and DV? No, the difference is between the groups or among the groups. Between groups of IV. Remember that. The difference is between or among groups of IV regarding DV. So these groups are different about certain things. For example, male, female students are different in grades, or they are not different in average grade. Make sense? There's no significant. I can just copy this, delete this, and copy this, and just make it a positive way. So that would be, there is a significant difference. There's a significant difference between groups of IV regarding D. So please read these two carefully and see the difference between the way that relations and differences are written, because you don't want to make small mistakes just for a hypothesis for exams, right? That's groups, that's relations. So remember that. So we have, yes, go ahead.
For the relation, should one of those say there is a significant relation?
Yes. Thank you. I forgot to put A here. I appreciate that. Thank you so much. So HO is there's no significant relation. HA is there's significant relation. HO for difference, there's no significant difference. There is a significant difference. Thank you so much for checking. All right, so going up, so association differences. So for all of these, right? So p-value is below 0.05. What do? You reject HO. Very nice, right? Okay. So we have, again, association differences. Associations, if you have one-on-one, continuous to continuous, that's scatter plot correlation, R-square, SRM, simple regression model conditions. If it's multiple continuous IV to continuous DV, scatter plot matrix, correlation matrix, R-square, multiple regression model, checking for assumptions or conditions. And for differences between categorical groups, so if you have two independent groups, what you run is, if you have two independent groups, you run t-test independent. If, let me copy this because it's the same thing but with a small difference. Copy and paste it here. So if categorical variable has two dependent this time, so dependent groups, then we use, its name is paired t-test. Paired t-test. You are supposed to have learned this in Stat 1 or basic statistics. The formula of t is different. Everything else is the same. P-value below 0.05, there is a difference. P-value is not below 0.05, there is no significant difference. As simple as that. Then what about if we have more groups? If, so let me paste this again because it's going to be the same thing. If categorical variable has this time more than two groups, more than two groups. If you have more than two groups, right, what do? We're going to use ANOVA test. We're going to use ANOVA test, analysis of variance. What is the difference between analysis of variance and t-test? Analysis of variance is for more than two groups. It finds if it can explore and find and tell us if there is a difference between multiple groups, more than two groups. T-test is for two groups. Okay. Now, again, the rule is the same. If p-value is below 0.05, what do you say? There is a significant difference between these groups. If p-value more than 0.05 or equal to, there is no significant difference. Okay. Let me add that up here because I want to make sure you are good. So here I write if p-value is below 0.05, reject HO. What does that mean? There is a significant relation. Right? Here, same. If the value is below 0.05, then you will reject HO again, which means there is a significant difference between groups, between IV and DV. Look at the difference. Here we say between IV and DV. Here we say between groups. Okay, they're completely different. Okay, for groups, the difference we find is between groups. For relations is between IV and DV. Okay, so next is so I think we don't have much time for practicing jump today. So just look at the big picture. Next time we will practice the same stuff using jump, and we'll continue with that. Okay. So if categorical variable more than two groups, we use ANOVA test. If two categorical IVs, and what are we looking at? We're looking at the association between the two categorical IVs. Do they affect each other when affecting the DV? Right? That's a cross effect test. I'll remind you that ANOVA test is a very wide, can be used in a wide range of problem solvings. So we focus on cross effect here. There are other applications for ANOVA test. We're not talking about those here. If two categorical IVs with one continuous DV, right? We use two ways ANOVA. Now, these are two categorical IVs. If I change one, can I make this page available? Did you take notes? You need to take notes, okay? But at the end, I will let you take pictures. At the end, I will let you take pictures. Okay? I will open all of it and I will let you take pictures. But if I give it to you, you won't study. So I want you to read, study, take notes, and so on. So if two categorical IVs, they're both categorical, right? We use two ways ANOVA. If one categorical IV and one continuous IV, right? The two IVs, one categorical IV, I make it orange, one continuous IV, make it like maybe blue. So 2, 2, 1, continuous DV. What test do we use? So that continuous IV, we call it because we are going to see if there is cross effect with the continuous IV. Again, this is cross effect analysis, okay? Cross effect analysis. So it's cross effect analysis. What do we call this continuous IV? We call it covariant. Covariant. The analysis is called ANCOVA. ANCOVA, analysis of covariance. Analysis of covariance. Analysis of covariance, similar to two-ways ANOVA, it covers wide range of analysis. What we are working here on is only the cross effect analysis, not the bigger picture, which can include regression and multiple regression analysis as well. So that is going to get very complicated if we want to talk about. However, chapter 25 and 26 talk about, especially 26 talks about ANCOVA with together with multiple regression, and that's very interesting to read. So read that part. You have already done the homework, hopefully, and you're good with that. But on exam, I won't ask ANCOVA in that level. I will just ask about cross effect. Is there a cross effect? How do you know? You look at the p-value of effect test. If below 0.05, there is cross effect. If not, there is no cross effect. Okay, so we'll continue these topics, and so this is how I think I could connect these topics together. Let me just put all in smaller versions so you can see them all in one time. And let me extend this part. Perfect. And this is recorded, and I will make this record available to you very soon as I can make sure this is complete. Oops. Okay, did I close the share? I want to close the record.